My name is Mark Kalaj, and I'm a fourth year graduate student in Professor Seth Cohen's lab. And my research focuses on the development of textile fibers for the protection of soldiers and civilians against chemical warfare agents. So we have a material known as a metal organic framework, or a MOF, that catalytically degrades these chemical warfare agents. And our goal is to combine this MOF with polymers and form textile fibers. So the idea is to make a hybrid material that has the catalytic properties of the MOF and the flexibility of the polymer, so that we can weave these or introduce them into actual clothing that people could wear. So one of my
Wow.
biggest motivators is that something I'm doing in the lab every day is something that's actually going to be able to impact the lives of people in the real world. So I think that's something that I really am passionate about, what kind of gets me up in the morning every day. And yeah, that's why I really like this research. The skills that I've learned here have been super critical in terms of mentorship. We've been able to mentor uh, different students and things of that sort who've come into the program after me. And in terms of more technical skills, we've learned several characterization methods, such as single crystal X-ray diffraction, powder X-ray diffraction, thermogravimetric analysis, all different types of microscopy, like scanning electron microscopy, that we have in the Nano 3 division down in engineering. I mean, it's really been nice. I think the nicest thing about being at UCSD is you can find any instrument on this campus, and that's like an invaluable resource that you have, because once you go out into the real world or in your own lab or something, you can say, okay, how do I tackle this problem? We enjoy the collaborative atmosphere. We pretty much every project we do on the metal organic framework research, we collaborate with the Nano 3 facility in engineering to get our microscopy work. Lately, when we've been making these polymeric type of materials, a lot of the polymer engineering and characterization is done down in nano engineering, or engineering. And it's been really nice. They're super nice groups to collaborate with, have a lot of ideas. And I think the coolest thing is that they see things from a different angle. Whereas we get caught up in the weeds of the chemistry part of it. They're like, okay, well, if you can fix this little thing, then we could make it really cool for engineering. And I think that's the beauty of collaboration, because we see things from different angles. So something that's cool to them might seem trivial to us, but in collaboration, we can come up with a new material from two different aspects.